Right, grade 12's matrics, my brothers and sisters of the academic struggle. Okay? A lot of pressure on you guys this year, and to all you guys that are under the sound of my voice, you guys are doing a great job. Okay? Great job despite the circumstances. Keep it up. I have all the faith in all of you. All the faith in the world I have in you guys. Trust me. Okay, so I assigned this to you guys as a class last week. Question 3, because it was on what we had learned last week, which was organic chemistry reactions. Okay, addition, elimination, and substitution reaction. And another reaction that exists all by itself is esterification, which we know is the addition of a carboxylic acid with an alcohol. Okay, and do believe I've demonstrated that. If not, I will obviously take some time to demonstrate it again. Okay, but esterification is almost considered a reaction on its own. Almost. Okay, almost. Anyway. In the flow diagram, question 3 states W, X, and Y, and Z, they are the letters that represent the different reactions that take place in this flow diagram. And A, B, C, and D, E are organic compounds. 3.1 was define the term homologous series. Any definition, or not any definition, but if your definition is not the same as the one that's in my memo, if you had one similar, of course, you'd get the marks. Okay, now homologous series, okay, is a series of similar compounds which have the same functional group and general formula, in which each member differs from the previous. So each homologous series differs from the previous one by a CH2 unit, okay, in the chain. Okay, another type of definition, if you had to put that same, what I just said now, if you said had a homologous series, is a group of compounds containing the same functional group and thus can be described by the same general formula. You also would have received the marks there. 3.2 was name the homologous series which or to which compound B belongs to. Now compound B is this one that I'm highlighting over here, not that, but that one that I highlighted, okay, under the letter B. CH3, CH2, CH2OH. So let's write that out over here. So compound B, okay, was written as CH3, CH2, CH2OH. So this is like molecular formula. As we can see that the OH is bonded to the CH2. Now, if you would like to further help your cause, okay, is to draw this out in structural formula. Nothing wrong with it. CH3, CH2, CH2, and yes, our OH. Okay, because we only have 3 carbons there anyway. Okay, so add in my hydrogens here for decorative purposes, of course. Got to decorate our molecule. Okay, so the question again was, to which homologous series does compound B belong to? We can see we got the presence of what? An OH, okay, which would be the functional group. Okay, so therefore, if that is the molecule's functional group, or more so, let me just undo that, this part over here. What homologous series does it belong to? Somebody said the answer before was alcohols. Okay, with the presence of the hydroxyl group. Okay, the OH. So we can clearly see it was an alcohol compound B. Okay, this was 3.2. Okay. 3.3a. Okay. Oopsie, almost knocked my coffee off the desk. State the type of reaction represented by the letter X. So we can see X goes from compound B here to compound C. Okay, so we go in from an alcohol and we have CH3, CH2, CH2OH. That looks like propanol. Okay, because of the 3 carbon. So it looks like propanol. And then we see that the OH hydroxyl group disappears. All right. So that disappears, right? But we're not left with CH3, CH2, CH2. We're left with one less hydrogen. Okay. Would anybody like to shed light on what type of reaction happened under the letter X? It is indeed elimination. Okay. Would anybody like to specify the type of elimination reaction that it is? Dehydration, okay? Because there is the presence of a missing hydrogen and the OH hydroxyl group, meaning H2O was taken away and we left with CH3, CH double bond to a CH2, condensed structural formula. So we've gone from a alcohol to an alkene. Okay? Looks like propene. Okay? Excuse me. I think Y was the next one. Y. We're going to look at where Y is. Just give me just 1 second. So Y is going from compound C to compound D, but looks like it involves some hydrohalogen or hydrohalogen there, HBr. So anybody like to shed light what compound Y is? Thank you. I know I said compound Y, but I meant process or reaction Y. Addition. Was addition. Yes. Thank you so much. Okay. Anybody like to specify the type of addition?
It's hydrohalogenation.
Excellent. Hydrohalogenation was the specified, the specific type of addition reaction that occurred because there was the presence of a hydrogen plus X, which is a halogen. In this case was HBr. Bromine is a halogen. Okay. Excellent. And cool, they haven't asked us about reaction Z just yet, or asking us to name any of the compounds, so we're okay for now. Or even W. Okay, 3.4 was give the structural formula of compound A. Okay, so now we know that compound B was an alcohol, and look what we're reacting it with. Okay, CH3COOH. Okay, who can tell me what homology series does that compound belong to? Or this compound that I'm highlighting belong to? Just the homology series, not the actual molecular name, organic name. Who can tell me the homology series?
Carboxylic acid.
Carboxylic acid. Okay, fantastic. So for compound A, 3.4, for compound A, we can clearly see that we have an alcohol plus a carboxylic acid. Right? Alcohol plus a carboxylic acid. Okay. Now we know how the alcohol looks as well as the carboxylic acid. And all we want is now the structural formula for what happens. Okay, so I'm going to draw the reactants first. So the alcohol was CH3, CH2, CH2OH. Okay, I'm going to omit these hydrogens just for now. Plus the carboxylic acid, which was CH3, I believe. C double bond oxygen OH. Okay, these empty spaces are all hydrogens. Okay, and we want the product. Okay, the product. Okay, so result obviously of an alcohol adding or being or reacting rather with a carboxylic acid, we know gives us an ester. So for 3.4, the answer, how that should look. Okay, which I will add in my hydrogens now, of course. This is my final product. The double bond of the carboxylic acid, oxygen, and the oxygen from the alcohol, and then the rest of the molecule, okay, of the alcohol is left. Okay, so you get the mark for the correct functional group and two marks for the correct number of carbons on either side of the molecule, so that would be 3 marks. Okay, so the functional group would be the double bond oxygen and the single bond oxygen. Okay, that'll be a mark, and of course the amount of carbons on either side, 1, 2, 3, 4, 5, of course. Okay, that's how it would look. 3.5. Give the IUPAC name of compound A. Okay, IUPAC name of compound A. Okay, so we'll name it from this side here. Propyl. Propyl from the alcohol. Alright. Ethanoate. Okay, so propyl from the propanol, so the alcohol named first, okay, and the second part of the compound, the name though, IUPAC name, is derived from the carboxylic acid. So we had, if we look at the diagram here, CH3COO, 2 carbons, ethanoic. Alright, so it was ethanoic acid, hence we have the name propyl ethanoate. Propyl from the propanol, okay, because we have a methyl, ethyl, and propyl. Propyl meaning 3 CH3s bonded after each other, or 3 carbons, bonded after each other. Okay, propyl, and which is CH2, CH2, CH3 at the end there. CH2, CH2, CH3, and of course these 2 carbons coming from the ethanoic acid, so propyl ethanoate. I just needed to take some time to just explain the naming convention and how we name an ester. Alright, excellent. That was 3.5. 3.6, okay, split into 3.6a and 3.6b. Okay. Pull up the question. Give the chemical formula of the catalyst used in reaction W. Okay, so reaction W, they're not asking for the name of it, but of course we know that compound A is an ester, so therefore the reaction that's represented by W must be esterification. Must be. But there's a catalyst used in esterification, okay, that hasn't been specified or written, okay, but the name of that catalyst, if you remember from my notes, is concentrated H2SO4, so I'm putting brackets conc for concentrated, okay, SO4, H2SO4, sulfuric acid, hydrogen sulfate. 3.6 B, the inorganic product of reaction W. Okay, the inorganic product of reaction W. Alright, the inorganic product of reaction W is in fact water. Okay, that's the inorganic, which is H2O. Okay, is in fact H2O. And of course you have OH there bonding to another type of OH, so water is somehow involved in esterification. Okay, but it is an inorganic product that is formed. Okay, at the end, so if you react the carboxylic acid with the alcohol, vice versa, alcohol with the carboxylic acid, you'll form your ester, and water will be the byproduct. Okay, because water is eliminated from the carboxylic acid. Okay, and obviously the OH group is eliminated from the carboxylic acid, and the hydrogen is eliminated from the alcohol. meaning water forms as the byproduct. So that's H2O. And there was a third question for 3.6. Let me just find it quickly. Give the IPAC name of compound D. Okay, which we went from this alkene to, which we know was an addition reaction, hydrohalogenation. So an alkane is going to be formed. More so a haloalkane forms. We just need the name of it. There's two ways you can name it. Either 1 bromopropane, okay, or the other name was 2 bromopropane, depending on where you decided to move your bromine. 2 bromopropane. (3.7) was name the reactant which reacts with compound C to form compound E in reaction Z. So let's look at reaction Z quickly. We need to name the reactant in that compound C reacts with to form compound E in reaction Z. So compound C reacts with something to form compound E. So we first need to, the way we can solve this type of question, firstly, by obviously first noticing and describing what compound C is. All right. Well, compound C we can clearly see is a alkene, and compound E looks like an alkane. I'm seeing CH3, CH2, CH3. So that looks like that is definitely an alkane for compound E, and compound C is an alkene, which we established that early on in the question. Now, of course, we need to find out what did compound C react with to get to compound E. Would anybody like to shed light on 3.7?
Hydrogen.
Excellent. Whoever said that, you beauty.
I just doing that.
What's that, Mr. Ravens? I didn't catch that. If you said hydrogen, you are right. If you said hydrogen, you are correct. Okay? Because they wanted the name. Now notice the question said, and in physics, these people are funny. Please, it bold, well not in bold, but in capital letters said the name. If you wrote H2, you would not get the mark. Because it said we wanted the name. Alright? The name. Okay? Cool. 3.8. 3.8. Using molecular formulae, write a balanced chemical equation to show the complete combustion of compound E. Okay. To show the complete combustion of compound E. Okay, so let me just look at compound E quickly, which is CH3, CH2, CH3. Now, if I'm going to combust that, I'm just looking at my memo, guys, for this answer, and this answer looks like it's slightly, it's very much confused. I don't understand why there's an O there, but this is how it should look. Okay, so that was a condensed structural formula there, all right, or a certain type or form of condensed structural formula, CH2, CH3, CH3, CH2, CH3, can't even remember the molecule, yes. So in the general formula for an alkane, we know is C 2N plus 2, wow, I can't even remember that. Wow, I'm just having a bad day. The general formula of an alkane, CN H2N plus 2. Okay, so if we do that, we see we got CnH2n plus 2. If we must, obviously got C3, and H2n is for the carbon, 3 plus 2. 3 times 2 is 6 plus 2 is 8. So the chemical molecular formula will be C3H8. Okay, that's the molecular formula. for compound E. And combustion, we want the full combustion balanced reaction. So we got C3H8 plus O2. That must obviously, whenever we combust anything, we get two products, which is CO2 plus H2O. Okay. So if you balance this equation, of course, you need to make sure we have all numbers on the left and the right that do add up. Okay, so for C3, I have 3 carbons. So I had to go put a 3 in front of the C in CO2. Okay, and that balanced my carbons. And then obviously my hydrogens on the left, I have 8. So yeah, I only have 2. So I put a 4 in front of the H2O to balance my hydrogens. Okay, so my carbons and my hydrogens are balanced. The only thing unbalanced were my oxygens. So on the right, I had 3 times 2, I had 6. And 4 times 1, I had 4. 6 plus 4 is 10. So I had to put a 5 in front of O2 to balance out my oxygens. So I actually have now 10 and 10 on each side. My equation is balanced. Okay, and so we'd get 3 marks for that. Okay, easy come, easy go. And then that was 3.8. 3.9 was a definition. Okay, define the term isomer. Okay, now isomer has one definition, but of course there are 3 different types of isomers that do exist. You get a chain, positional, and functional. Okay. But a isomer, though, there are organic compounds that have the same molecular formula, but of course different structural formula. Okay, that is the definition, the formal definition for a isomer. Although there are 3 that exist, 3 different types. Okay, because we can differentiate between the 2 of them. All 3 still give testament to the main isomer definition, which is same organic compounds with the same molecular formula but different structural formula. 3.10 though, give the name of the functional isomer of compound A. So let's look at compound A. Compound A we did name. Alright, compound A I think we named in question 3.5. Give the IPAC name of compound A. So we named it as propyl ethanoate, which was an ester, and the functional isomer. The definition, though, for a functional isomer quickly. Okay. The functional isomer are molecules with the same molecular formula, but with different functional groups, and therefore they all belong to different homologous series. Okay. So if I had propanoic acid, and that will be the same molecular formula as methyl ethanoate, but I've changed the functional groups. Okay, no longer is it just a C double bond oxygen for carboxylic acid, but for an ester, the double bond oxygen to a single bond oxygen onto 1 carbon. So we got an ester here. So I mentioned that carboxylic acids and esters are functional isomers of each other, so long as they have the same amount of carbons with them. Okay, so here propyl ethanoate had 5 carbons in them. So a name for a functional isomer of propyl ethanoate. Would anybody like to take a shot at 3.10? Okay, propyl ethanoate, functional isomer of it, which we just switch around the functional group.
Pentanoic acid.
Excellent. Pentanoic acid. Pentanoic acid, a functional isomer. Again, propyl ethanoate and pentanoic acid both have the same molecular formula but with different structural groups. Therefore, they belong to different homologous series. Propyl ethanoate belongs to esters. Pentanoic acid, of course, belongs to carboxylic acids. And that's my session with you guys, grade 12s. Thank you so much for joining me on just the marking of this question, taking through what is a common exam style question that pops up in every exam at the end of the year for finals, as well as in tests in organic chemistry. And this is really fun once we nail the section and we actually learn this very well, how to recognize these reactions, what is taking place. Then these questions start becoming fun, and we actually will enjoy seeing them in an exam setting. Stay tuned for our next session. We'll be wrapping up organic chemistry.